Alright, so girls, here's a question, listening. We need to solve for x. The first question you need to always ask yourself is, can you make the base numbers on both sides? Can you make the same base number on both sides? In this case, I know I can because 4 and 2, they're both factors of 2. So girls, I'm going to try and change both of these into power of, with a base number of 2. If I change it into 2, that means this becomes 2x. Does that make sense? Because 4 is equal to 2 squared. So because there's an x, you're just basically doing 2 times x. Okay? Now, half in terms of power is minus 1. Yeah? And then what you do after that is do the second part, solve the equation of the powers. So all you need to do now is just look at the powers. So write them out separately like this, and then just solve it. All right? So that's how you solve exponential equations. Make the base numbers the same, solve the powers. Okay? Let's apply the same thing here. Tricky one though. Is there a number that both goes into 3 and 1? It doesn't make sense. Here's a trick. Girls, 1. Anything to the power of
0.
Yeah. So girls, this is how you do this one. So this is the same thing as writing 3 to the power of 0. Okay, that's a trick. Okay, so now that we have both base of 3, girls, can you listen? All right. Now I can just solve these two. So just quickly, if I do that, x is equal to a quarter. Okay. All right. Now, if you get a question like this, 4 times something, the first instinct that you want to do is actually get rid of the 4. Now dividing it to the other side. Okay. So 32 to the power of x is equal to 1 over 16 divided by 4 is like doing 1 over 16 times 4. I don't know what that is. Can someone do it?
64.
Okay, good. 64. Now let's think. By trial and error, we need to think of a number that I can change both into a base of. Sorry?
2 to the power of 5.
Okay, so 2 to the power of 5. Yep, that works. And in terms of 2, this is 2 to the power of what?
6.
Is-
Minus 6.
Oh yeah, minus 6, yeah. Yeah, because remember, this is the same thing as 1 over 2 to the power of 6, and that becomes that. Okay? You with me?
Yeah.
So now I can just equate these two. So x is equal to minus 6 over 5. Okay? All right. Similar question. Once again, we got 4 and 16. I'm going to leave this as 4 because I know I can change this into base of 4. But then I have to multiply the power by 2. Yeah, because 16 is 4 squared. So you're multiplying the 2 with that. So now let's just solve the powers. So we got x plus 2 is equal to expanding the bracket. You got that. So x is equal to, oh, is it just 0? Oh, it's x equals 0.
Wow.
Okay. And girls, in the exam, if you had spare time, you can always check your answer by putting 0 back into the question. Yeah? And in this case, can you see it will work? Because this will be 4 to the power of 0 plus 2 is equal to 16 to the power of 0 plus 1. 4 squared is equal to 16. So that's how you check your answer in the exam. Okay? Now, let's go to the type of exam style questions, HSC style. Okay? Girls, when you see something like this, you need to be able to spot out that this is actually a quadratic equation form. Okay? Here's what you do. Firstly, girls, notice how they're both, like they're all in terms of 7. Yeah? So the first instinct is to change that number into base of 7. You want to make it like consistent. So if I change that into base of 7, then that means 49 remember is 7 squared. So then this is 2x. Okay? And then write down the rest. And then from here, what you want to do, let's just say let let's say let
7 to the power of x. Minus x now.
okay, let's just say big X is 7 to the power of x.
25 letters in the alphabet and the letter x.
It's just a generic letter, okay? Girls, from here, if I wanted 7 squared x or 7 to the power of 2x, then in terms of big X, this is x squared. Okay, you need to be able to spot that, okay? Because if you square this, you get that. So what am I trying to say? What I'm trying to say is now I can write this as x squared. This is minus 6x. Can you see that? You're just replacing that with x's, with a 6 in front. And then you got the minus 7. And can you see this is a quadratic equation?
Yes.
Yeah? I can factorize that. So just quickly, if I do factorize it, I get this. So here, now don't leave your answer just left like that. I've got to go back now. What does x represent in the first place? Yeah, so you want to make sure you replace it back. Okay, replace it back. So, and now let's get the final answer. 7 to the power of what is 7? 1. So my first answer is x equals to 1. And my second answer, 7 to the power of something is minus 1. Oh, that's a bit tricky. Any suggestion? Girls, if you're ever not sure what power goes into what, you can always use that rule. Okay, I'll show you how. Firstly, girls, we learned this. How do I make x a subject? Change this back into log form. What would that be? Yeah, that's right. Girls, you can never have a negative number. Firstly, do you get how I got from here to here? Changing into log form. So our whole exercise has been based on this. When you have a negative number for log, there's no solution. Okay? When you have a negative number, so that means there is no solution here. Okay? Or if you want to further check, from last lesson, you know how I told you can evaluate the value of log in your calculator for any type of log? Well, in this case, if you wanted to actually find out what the value is for here, top number goes to the top, bottom number goes to the bottom, and if you actually type that in the calculator, you'll get math error. All right? So my point is, if you ever get a negative number on the other side, there's no solution. So the only answer is x equals to 1. Okay? But that's the main technique I want to show you. All right? Which I am going to apply again in that example, but keep that in mind. It's not common, but it does pop up here and there quite frequently. Okay, now that we've learned how to solve exponential, girls, let's solve logarithmic equation. Same technique. All right, when you solve log, girls, like this, what you want to do is change it back into exponential form. Yeah? So how do I change that into exponential form? One over 64. Yeah? You with me? Oh, sorry. Yep, you're right. X to the power of minus 3. Yep. Is that good? Okay. Now, see how it's got a negative power? So isn't it that? Yeah? So you just have to compare these two. So x is equal to just, yeah. Okay, so that's how you solve logarithmic equation in simple form. Okay? This is what you change it into exponential form when it's just singular log. When you have two logs though, you can't do that. You have to use one of the log laws. And what does that mean? Girls, when you take away the two logs, it's the same thing as dividing it. Yeah? So I can write this as log 10 x plus 1 on top over, yeah, so it's always the first one on top, second one at the bottom, and that's equal to 1. Okay? And then from here, what you want to do is change it back into exponential form like I did there. Okay? So bring that there. So now I have x plus 1 over x minus 8, 10 to the power of 1, yeah, which is just 10, so I'm going to get rid of the 1. And then it's just your normal equation. Multiply that across, so I've got x plus 1 is equal to 10 times x minus 8. So just quickly, you girls know what I'm doing now, so I'm just going to skip ahead. So x should be equal to, that becomes 9x. Is it just 9? Yeah? So that's how you do it, okay? So when it's solving logarithmic equation, use one of the log laws, change it into exponential form, then solve it. So I'll write that down. After you use the law, change to... Okay, now this is another application of what I did here, quadratic, okay? As soon as you see something squared and like not squared and a number, you need to think of quadratic form. So what I'm trying to say is if you see something in this form and some random number, you need to know this is quadratic form, okay? So remember that template. But in here, girls, what you do is you let big X is equal to ln x, okay? Okay, so this one is then x squared. Now here's the tricky part though, right? With this, now this ln, it's technically this. A lot of students aren't able to see that. Okay? The reason why you want to be able to see this first is because what can I do? Bring the 2 down. That's right. So this is really the same thing as writing 2 log EX or 2 ln x. Okay? The reason why I need this is because now I can write, for this one is now the same thing as writing minus 2x. Okay? Because remember, we just let this equal to big X, so 2x. Does that make sense? Okay? And then plus 1 is equal to 0, and we can solve that. Yeah, it's just x minus 1 squared. So from here, big X is equal to 1, but what does big X represent? ln x. And can you see the, now, I'm going to change this into log EX just because it's easier to solve. So then x is equal to e to the power of 1, or just e. Okay, so that's how you solve this type of questions. I haven't exposed you enough to this type of questions, but that's what you got to be able to do. All right?